Welcome to June 6 LeetCode Challenge, intersection of two linked lists. Given the head of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. So we see the linked list points here, and then both 2 pointers point to C1. The test cases are generated such that there is no cycle anywhere in the entire linked list structure. Note that the linked list must retain the original structure after the function returns. So we have custom judge here that inputs the judge given as follows. So your program might not given these inputs directly, depending on the programming language. So we have the function called intersect val, which the value node intersection occurs. This is 0 if there is no intersection of nodes. You have list A, which is the first linked list, list B, which is the second linked list, skip A, which is the number of nodes to skip ahead of list A, starting from the head to get the intersection of the node. We have skip B, which is the number of nodes skipped ahead in list B, starting from the head node to get the intersection of that node, of that list, I should say. The judge will then give the linked structure based on the inputs to pass the head A and head B to your program. If returned correctly, the intersect node will then your solution will be accepted. So, given this function here, we have list A, right? Given this as the top one, list B is the bottom one, and we want to intersect at node 8. So we say that we skip 2 for A, so 0, 1, 2, which gets to here, and we skip 3 for node B, so 0, 1, 2, 3, and then we get that the return the intersection of two linked lists. So let's see, the node's value of 8 must not be 0 if the two linked lists are intersected, which is true. The head of A reads as 41845. From the head of B, it reads 561845. The two nodes are intersected at 8. So there's 2 nodes from A and 3 nodes from B. Similar idea to here. We have node list A 19124, and then list B being 324. They intersect at node value 2, which is number 3, index 3 on skip on list A, and index 1 on list B. And we're given these two lists here that intersect at 0, as in there's no intersection. So the list, well, all that just reading. So the number of nodes, list A is M, list B is N. The value of the nodes are between 1, number of M and N is between 1 to 3 times 10 to the 4. The value of the nodes are between 1 to 10 to the 5. Skip A and skip B are between 0 to M and N respectively. We have the value of the intersection is 0 if A and B have no intersection, and the value of intersection equals A. Skip A index at list A, skip B index at list B. If list A and B intersect, could you write the solution in m plus n time and using only constant memory? Alright, let's so we can actually use 2 pointers for this. So say for this approach, we initialize 2 pointers which are pointing to the head of each linked list. Then we make the pointers run through both linked lists i.e. at m plus n length. By doing so, we hit an intersection point if there is one. So if pointer number 1 does not equal pointer number 2, which compares the hashes of the two objects, then the problem states that both inputs have the same tail, right? The same tail, which means that they link their intersection. So both linked lists are merging at some point. This means that if we have list A or list B equal to in the case that value A equal to value B, that means in some cases there is an intersection, so it means that the hash of 1 equals the hash of 2. So we could just locally create 2 pointers to separate the linked lists, and then point towards the tail. So let's go about doing that. So say we call this pointer, no, call it 1 for pointer 1, and that's going to be head A, and then pointer 2, which is going to be called 2, and that's going to be head B. So while 1 is not equal to 2, we assign 1 to be the head of B if 1 is none, else 1 dot next. Likewise, we do the same thing. 2 equal to head A if 2 is none, else 2 dot next. And then return the instruction of either 1 or 2, which is just return 1 for now. Run this code. So this runs at big O of m plus n time complexity, and memory complexity just returns big O of constant space, because we basically return everything as we would just basically return the original node, which is we're not, yeah, let's see, we retain the original structure, so therefore we don't actually change the nodes themselves, the linked list themselves. Alright, that's it. Have a great day, guys.